Okay, so let's proceed to calorimetry. Sure naman ako. Verify lang, recording na. Okay. Sige. Okay, so in terms of, tingnan natin kung tama, 64. So, in terms of calorimetry, sabi dito, it is the term used to describe the measurement of heat flow. Experiments are carried out in devices called calorimeters. So, in terms of calorimetry, think ko around 3 days, nagpa-travel na heat, no? Nagbibiyahe na heat. So, if the instrument is thermally isolated from the rest of the universe, the only heat flow that must be considered is that between the system being studied and the immediate surroundings whose temperature can be measured. So, in this scenario, in calorimetry, if you observe yung future slides natin, yung mga nangyari sa calorimetry is the same as what happened in, saan na ba yan? In this problem, no? Wherein ina-isolate natin yung water from the rest of the environment, no? Ang kaibahan lang dito sa calorimetry, hindi na yun uh, in terms of tawag dito, parang in theory lang yung isolation, but rather ginagawa talaga natin siya um, ng tawag dito, process para ma-isolate yung mga materials. Okay, so first you have the two-step process in calorimetric measurements. So first you have the calibration in which a known amount of heat is generated in the apparatus. And for number two, the actual measurement in which we determine the amount of heat absorbed or released in the reaction of a known material. So therefore, yung unang gagawin natin dito is to calibrate. Alamin natin kung ilan ba yung specific heat na ng material, or rather hindi ng material but rather the calorimeter itself. Ilan ba yung parang tinatawag siya dito as calorimetric constant, and then yung actual measurement ng material. So the calorimeter constant is the heat capacity of a particular object or set of objects rather than that of a material. It is the heat capacity per calorimeter with just one calorimeter. Ibig sabihin, if you observe yung mga last na specific heats natin, specific siya sa material. For example, specific heat of water, specific heat of ano ba yun? Gold, of aluminum, of iron, no? Yung specific heat mismo ng material yung inaalam natin. But dito sa calorimetry, yung calorimeter constant, siya yung specific heat ng mismong calorimeter. So if you can observe, may picture ata tayo ng calorimeter dito. If you look at this calorimeter, ma-observe natin, we have different materials here. May tubig siya, may stirrer, may thermometer, and those materials absorbs heat. Nag-absorb siya ng init. Kaya di mo siya pwedeng i-isolate lang na water, araw ka ng specific heat. Yung thermometer, yung material nito, yung glass, for example, have different specific heat. But if in terms of calorimetry constant, in terms of the calorimeter constant, tinitingnan natin siya as a whole. So, pag nag-release kita, we have this formula. Known amount of heat equals the calorimeter constant multiplied by the change in temperature. So, kung alam mo yung heat na to, yung inintroduce mo na heat dun sa isang system, madedetermine mo na din yung calorimeter as long as you divide the known heat by the change in temperature ng system. Okay, so malaman mo na yung calorimeter constant or the specific heat of all the materials na yan dito. Okay, so basahin ko lang muna. A bomb calorimeter carries out a reaction at constant volume and with no heat flow between the calorimeter and the outside world. The diagram on the right shows the standard choice of system and surroundings for a bomb calorimetry experiment. The system consists of the contents of the bomb itself, And the surroundings include the bomb and the water bath surrounding it. We assume that no heat is exchanged with the rest of the universe outside the insulated walls of the apparatus. So, ma-observe natin dito na because you have the insulation, na isolated na tatanggal natin yung factor ng pag-release ng init from surroundings papunta dun sa actual surrounding talaga, no? Of course, meron pa yung environment kung saan ang laboratory to. So nawawala yung heat transfer. Kaya nga dito, sabi dito sa PowerPoint natin, no heat flow. Walang papasok na init and walang lalabas na init dun sa mismong surroundings ng uh, material. Okay? So that's why ang kailangan lang natin dito is the heat lost by the system and the heat added on the surroundings. Okay? So by that method, malalaman natin kung ilang ilan ba yung kayang init ng material, no? Na sinasubject natin sa test sa bomb calorimeter. Oh, example to, sige. Sabi dito, a calorimeter is to be used to compare the energy content of some fuels. In the calibration of the calorimeter, an electrical resistance heater supplies 100 joules of heat and a temperature increase of 0.850 degrees Celsius is observed. Then, 0.245 grams of particular fuel is burned in the same calorimeter and the temperature increased by 5.23 degrees Celsius. We are asked to calculate the energy density of this fuel, which is the amount of energy liberated per gram of fuel burned. So, in this problem, step by step, first will be the calibration. Sa step 1 natin, in terms of calibration, ang inaalam natin is the calorimeter constant, no? By using the formula Q equals to the calorimeter constant multiplied by the change in temperature. Since we already know the heat supplied as 100 joules, aalamin na lang natin kung ilan ba yung change in temperature dito sa surroundings. Going back, ibig sabihin, yung sinupply mo ditong heat dito sa area na to is at 100 joules. So, pag nag-supply ka ng init digdi, tataas ngayon yung temperature dito or rather yung reading dito sa thermometer. Okay? Take note na itong ginagawa natin is more on calibration pa lang to determine the calorimeter constant. Okay? So after you determine the calorimeter constant by dividing the known heat supplied by the change in temperature, ang makukuha natin dito is ilan ba to? Hindi na to. Hanggang dito lang to. So we have now 100 divided by 0.850. So meron tayong 117 point, 65, let's say 65 joules per degree Celsius. So this is now the calorimeter constant. So we are asked to calculate the energy density of this fuel. So ang sunod naman is yung step 2. Take note, sabi dito, step 2, going back, is the actual measurement in which we determine the amount of heat absorbed or released in the reaction of a known material. So, ito na yung gamitin natin. So, since yung calorimeter constant natin, based on our computation is 117.65 joule per degree Celsius. So we go back to the calorimeter. As you can observe, kung nakikita nyo pa, you have this certain equation dito since isolated siya sa environment, ano? So you have the heat that is released by the system is equivalent to the heat absorbed by the surroundings. No? Tanggalin natin absorb surroundings. So halin duman sa system, duman sa ininit mong fuel, malaog si init na to, duman na sa surroundings. So going back to our problem, sabi dito, saan na ba to? Ito, then 0.245 gram of a particular fuel is burned in the same calorimeter. So this one, itong sinunog na to, this one is already part. It is now the one burned in the system. Kumbaga, siya yung tawag dito. Um, siya yung nandun mismo sa under observation, kumbaga. So we have now the one burned by the system. So we have MC and then the change in temperature. This is equivalent to the change in temperature ng surroundings, which is, ito na yung sa uh, Q equals 2 in terms of the calorimeter constant. This one is equivalent to Q equals to the calorimeter constant multiplied by the change in temperature also. So, latag lang natin tong part na equation. So, calorimeter constant multiplied by the change in temperature. Maliputan. Okay. So, based dito, latag na natin yung mga known value. So, as you can observe, there is an increase in temperature by 5.23 degrees Celsius. So, dito, alam ko hindi na to kasamang delta T na to in terms of system. So, may siyang per joule na lang ang style. Ano? So, may itong, alam ba to? 0.245. 245 multiplied by the specific heat C as equivalent to the calorimeter constant of 117.65 multiplied by the change in temperature of 5.23 degree Celsius. So, ayan. So, based dito, yung heat that was released by the system is equivalent to 117.65 times 5.23. You have here 615.3 joule per degree Celsius. So dito, you have 0.245 multiplied by the specific heat na C. So as you can observe, in terms of the system, tinanggal ko na to. Hindi ko na sinama yung change in temperature kasi yung change in temperature dito will be dito part already of the tawag dito, parang calorimeter constant. Dito na siya. No? So this is equivalent now to, divide natin to by 0.245, dividing both sides by 0.245. This one is in grams. You determine therefore the specific heat of the system, or rather the fuel, as 615.3 divided by 0.245. So here you have the specific heat of 2,511.47 joule per gram degree Celsius. Ayan. So, Teka. Okay, so big pause ko lang sa recording kasi verify ko din yung dito sa libro in terms of the solution. No? So dito, nag-jump na katalig sa specific heat, but rather, in terms of the problem, ang hinahanap is the energy density of the fuel. Kumbaga, ano, kung ilan yung energy na pwedeng ma-extract dun sa fuel per mass of the fuel. So dito, using the calorimeter constant, sabi natin, the heat that is available, no, is equivalent to the same, 117.65 times 5.23. So the heat na record sa calorimeter is equivalent to 615.3 joules. Okay? 615.3 joules. So, since this one is from the calorimeter, using the calorimeter constant, actually, this value is what is released by the system. Okay, siya yung binigay ng system. So we can say that the heat nung, let's say, fuel is also equivalent to 615.3 joules. So siya si pig-release. So since pig-release siya, it should be negative. Negative yung value niya. No, 615.3 yung na-extract na energy from the fuel. So same lang siya Same lang siya nito. Kaya lang negative na kasi ni-release. Now, from this value, you have what we call the energy density, wherein this is the amount of energy that we can extract per mass of the material. So this is equivalent to negative Q of the fuel divided by the mass of the fuel. So as you can observe, halos wala namang pinagbago dito sa ginawa natin. We still divided it by the mass. However, since negative to, so negative multiplied by negative 615 joules divided by 0.245 grams. So therefore, this is equivalent to 511.5 joule per gram of fuel. So ito na ngayon yung energy density. Therefore, we can extract 2,511.5 joules per gram of the material. So this one is important. So this is important in determining how much energy can be extracted from the material, as well as how efficient can your machine nga sa pag-convert kaning energy na ni to other forms. No, for example, ining energy may certain gram kaning material tapos kay po ang kayang ma-release niya is 2,511.5. However, based naman sa machine na nagibo mo, ang na-extract lang na energy is, let's say, 1,000 joules. No? Or rather, dun sa furnace, kumbaga kung may suluan ka mo, may gatungan ka mo, so na-extract lang na energy is 1,000 joules. So, based doon, nakukuha natin kung ilan ba yung efficiency. No? Kung gaano kagaling yung system mo or yung machine mo sa pag-convert ng energy. Take note that, sabi nga natin, energy cannot be created nor destroyed. It can only be converted from one form to another. So therefore, pag-convert natin to useful work, mayroon na tayong mga losses doon. Okay? So that is one item. Ano pa tayo ng other item dito? So ayan. Another one, a calorimeter is to be used to compare the energy content of some fuels In the calibration of the calorimeter, an electrical resistance heater supplies 100 joules of heat and ano na pala solution na ito yung solution pala kanina. Okay. Ayan. Next, the combustion of naphthalene, C10H8, which releases 5,150.1 kilojoule per mole, is often used to calibrate calorimeters. 1.05 gram sample of naphthalene is burned in a calorimeter, producing a temperature rise of 3.86 degrees Celsius. Burning a 1.83 gram sample of coal in the same calorimeter causes a temperature change of 4.9 degrees Celsius. We are asked what is the energy density of the coal. So, therefore, following the same method, pwede siguro dito lang tayo magsulat, kaya naman siguro. Following the same method uh, in calorimetry, let us first determine what is the calorimetric constant. Okay, so this one is again equivalent to bilan ba to? Q per change in temperature, no, from our past equation. However, in this problem, we are given in terms of moles. Okay? So, pwede naman. Wala namang problema. So, tingnan natin 1.05 gram sample. So, we have the mass of 1.05 grams and then binigyan din tayo ng parang ano, tawag dito, specific heat niya in terms of moles. So therefore, we first convert this to moles. So C10H8 for carbon, ilan ba yung specific heat ng carbon? Specific heat molar mass. We have 12. So C is equivalent to 12 gram per mole. And then H is 1 gram per mole. So using this data, we multiply this by 10 and then we multiply this by 8. You have the total of, ito what, 20. This one is 8. So you have C10, H8. Yung molar mass niya should be equivalent to 128, no? Gram per mole. So if you have 100, baka kulangin tayo dito. Dito na lang tayo, lipat natin. So kung ang C10, H8 has a molar mass of 128 gram per mole. And you have the mass of the tawag dito, naphthalene as equivalent to ilan ba yung 105? 1.05 rather, 1.05 grams. So in terms of the moles, the number of moles here would be equivalent to 128, ay rather 1.05 grams. Yung mass, lagay mo natin yung formula. Mass multiplied by, or rather divided by the molar mass. Yeah. Over the molar mass, which is equivalent also to 1.05 multiplied by mole per 128 gram. No multiplication. Yeah. So meron tayo dito moles na 1.05 divided by 128. So we have N of 8.203 times 10 raised to negative 3. So yeah. This one is in terms na sa moles. So, going back, Yung heat na nirelease ng naphthalene is equivalent therefore if you have a specific heat of 5150 kilojoule per mole, multiply lang natin to by 8.203 times 10 raised to negative 3 moles, you can already determine what is Q, no? So the heat generated by this naphthalene, multiply natin by 5150, uh, this is equivalent to 42.25 kilojoules. Or in terms of joules, this is equivalent to, multiply natin by 1,000 for 2,246. Okay. 42,246 joules. So going back, step 1 natin, calorimetry constant. So sabi natin, Q is the equivalent to the calorimetry constant multiplied by the change in temperature. And manipulating this equation, you now have the calorimetry constant as equivalent therefore to Q divided by the change in temperature. Going back to our problem, the change in temperature is, nung ano siya, is 3.86. So therefore, yung Q natin, going back, na-determine natin as 42,246 joules divided by the change in temperature na 3.86. So therefore, the calorimetry constant is equivalent to how much? Divide by 3.86. You have 10944.6 joule per degree Celsius. So that is now the calorimetry constant. Okay. Next, we have this another scenario. Burning a 1.83 gram sample of coal in the same calorimeter causes a temperature rise of 4.9 degrees Celsius. So we're asked what is the energy density of the coal. No, so, ayan. For step 2 na tayo. Okay. And, teka lang, medyo tema. Ala. Kung ano na i-click ko. Wait lang, guys. Error naman naman. Laptop. International parties of 10. 2.10. Pala araw-araw. Okay, so natapos ang ano ko. Bari ako dito. Kaya nun, nag-error kaya. Nalat lang. Oh, shucks. Dati lang ba rin? Ayan. Let's go back. Kaya tayo. So, sabi dito, another given is the mass of coal, which is equivalent to, ilan ba to? 1.83. 1.83 gram. And then there is a change in temperature that is equivalent to 4.9. 4.9 degrees Celsius. So, if we determine the heat from the calorimetry constant by the change caused by the coal, um, nagkaroon tayo ng change in temperature na 4.9. So therefore, if you have 1,944.6 joules per degree Celsius multiplied by 4.9 degrees Celsius. So we have now the Q as equivalent to times 4.9. We have the heat released by the coal as 53,628.46. So in terms of the energy density, so we have here of Q divided by the mass for the energy density. So of course, this one should be negative. Ano kasi siya yung ni-release nung uh, siya yung na-absorb ng surroundings and kumbaga ito yung na-absorb ng surroundings. So since na yung surroundings natin is yung mismong calorimeter, no? We go back to our system, ay to our parang equations, no? That the heat that is generated by the fuel is equivalent to the negative, or rather released by the fuel is equivalent to the negative heat absorbed by the surroundings. No? Kasi in terms of fuel, siya yung nag-release ng heat. So therefore, in terms of the energy density, this will again be negative na value ng fuel, wherein we have negative multiplied by negative uh, 53628.46 joules. So we divide this by the mass of the coal of 1.83 grams. Therefore, the energy density is equivalent to how much? Divide natin by 1.83. We have 29,305.16 joule per mass of coal. So 29.3 or 29.3 kilojoule per mass. So ito yung ma-generate natin na heat per gram pala tayo, it's not mass but grams per gram of coal. Okay? So, ayan.